Have you ever wondered how your AI just gets you? You know, how it finishes your sentences or finds that perfect search result? It feels like straight up magic. But today, we are going to pull back the curtain on the secret language that makes all of it work. I mean, really think about that for a second. How on earth does your phone, which is just a machine that only understands ones and zeros, know that king and queen belong together, but that king and cabbage are from completely different worlds? It's not magic. It's actually an incredibly clever bit of engineering. So, to figure this out, we're going to go on a little journey together. First, we'll look at the big puzzle AI has to solve with language. Then, we'll get to the solution, this wild idea of turning words into map coordinates. We'll walk through a real example, see how AI actually finds related words, and then we'll see why this whole secret map idea powers so much of the tech that you and I use every single day. All right, let's dive in. Part 1, the AI language puzzle. At its very core, the problem is this. How do you teach a machine, a thing of pure logic and math, to understand and read between the lines of our messy, emotional, and beautiful human language? See, here's the fundamental disconnect, right? To a computer, a word like king is just a bunch of letters. K-I-N-G. It has zero built-in concept of royalty or power or chess. It just sees data. So the big question is, how in the world do we bridge this massive gap between our rich contextual language and their world of pure numbers? Well, how do we solve it? This is where things get really, really clever. Engineers had this brilliant idea. What if we could translate all of language, every word, onto a giant, invisible map of meaning? And that right there is the secret sauce. The solution is to give every single word its own unique set of coordinates, just like you'd find a city on a map. This is the big aha moment in understanding how AI actually makes sense of what we're saying. Now, these special coordinates have a technical name, an AI vector. And look, don't let that name scare you. It's literally just a list of numbers. But it's not a random list. Oh no. Each number is super carefully chosen to pinpoint a word's exact location on that map of meaning, all based on the company it keeps, the other words it usually hangs out with. You know, the map analogy is almost perfect. Think about it. On a regular geographic map, the points are cities, right? The coordinates are latitude and longitude, and the distance between them is, well, physical space. Now, on our meaning map, the points are words. The coordinates are those vector numbers. And the distance, that's the key. The distance represents how closely related their meanings are. Okay, let's make this feel a little more real. Remember our friends Rama, Sita, and Hanuman? Let's actually plot them on our map and see exactly how this works in practice. Okay, so just imagine an AI that's been trained by reading countless books, ancient texts, and websites. It sees the words Rama and Sita appearing together all the time, in similar contexts, stories about royalty, devotion, and epic adventures. Same with Hanuman. Because of this constant association, the AI starts to learn, hey, these words are contextually related, so when it assigns them their vector coordinates, it plots them as super close neighbors on our map of meaning. They basically become this little tight-knit cluster in this vast, vast space of words. And here is where it all just clicks into place. We can actually measure the conceptual distance between these words. So the distance between Rama and Sita, it's tiny, like a 10. The distance to Hanuman, a little bit further, a 15, but still really close. But the distance between Rama and a totally unrelated word like cabbage, it's massive. It's way out there at 95. The AI has learned that cabbage just doesn't belong in that neighborhood. Okay, so we've got this incredible map. But how does an AI actually use it to find the most similar word? This is where the math becomes incredibly powerful and, honestly, pretty simple. So, look, if you remember just one thing from all of this, make it this. Distance is meaning. The whole complex, mind-bending system boils down to that one beautiful rule. Shorter distance, closer meaning. That is the law of the land in AI language. So here's how it works, in 4 easy steps. First, the AI gets a starting word, let's say Rama. Then it does a lightning-fast calculation, measuring the distance from the Rama vector to every single other word vector on its map. Third, it just looks for the word with the absolute shortest distance. And boom, that's it. That closest neighbor, in this case almost certainly Sita, is presented as the most related word. Simple as that. Now, I know this might all sound a little abstract, but I promise you, this map of meaning is one of the most important ideas in all of modern AI. So let's connect it directly to the apps you're probably using every single day.
You might not see it, but this system is this silent engine running your digital life. That search engine that just knows what you mean, not just the words you typed, that's Vectors. That streaming service that suggests the absolute perfect movie, it's just finding the closest neighbor to the last thing you watched. It's in translation tools, it's in your phone's autocorrect, it's in predictive text. It is absolutely everywhere.
So the next time your phone suggests the perfect word to finish your sentence, or a search engine gives you exactly what you were hoping for, just remember what's really going on under the hood. It's not magic, it's not understanding in the human sense, it's just an incredibly fast and brilliant mathematician measuring distances on this vast, invisible map of words to find the closest possible neighbor. And that kind of leaves us with a really fascinating final thought, doesn't it? We've managed to map the intricate relationships within human language. So if we can do that, what's next? What other complex human concepts, things like images or sounds, or maybe even abstract ideas, can AI learn to map and measure and navigate? What do you think is the next destination for it to explore?